Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely brilliant day. Let me go ahead and fix this camera real quick. Is it fixed? I think it's fine. Yeah, that's okay. Okay, so what are we going to do today? Well, today we're going to continue what we were working on yesterday and the day before that and the day before that, and that is working on our lens visualization. Now, yesterday something really cool happened that I don't know how to describe. So I'm just going to show you the visualization and hope that you're amazed. Because it happened at the end of stream and it's absolutely beautiful in my opinion. So let me go ahead and cd into the appropriate directory, projects, Simuleos, and of course Geometrical Optics. And let me just run the make command. It's going to take a little bit of time. Not that much time, but a little bit of time. Basically what we're doing is we're sending 10 rays of light, hey Gustor, thanks for coming in, into the lens. And then what we're doing is we are modifying the refractive index of the error function of 1 over r in the lens itself. And we're watching the light basically slowly but surely be allowed into the lens and then be modified by this error function. And when it comes out, it looks crazy. Like it's one of those things that's not intuitive, but I have to kind of trust the code a little bit. So what we need to do, or what I need to do, is check to see whether this is actually a physical result. But there's a lot of other things that we need to do. So in order to kind of get at these things that need to be done, what we need to kind of do today is fix up the code, make it run a little bit smoother for a number of different cases, and of course, one second, add in the ability to dynamically change the lens that we are wanting to use for each of the simulations. So this is just a matter of incorporating new, I suppose, functions for each individual lens. Gustorn wrote up a good way to do it, and I will probably be taking some of that throughout the episode. Okay, so here's the image. Let's go ahead and do Mirage, temp, and of course, image 00, starting at the start, PNG. So this is the first image in the visualization. Here's a drawing of the lens. There is the, let's say the, I guess, visualization of the interior index. Here's the first time step. Now this is actually really cool for a number of reasons. First of all, the interior index is being multiplied by basically 0, right? Which means only the ray that is hitting the exact center of the sphere should go through. And that's exactly what we see. Everything else is reflected out. As we increase the refractive index, you note that there's small changes to the reflectivity of the light, but it's not that big until here, when light enters the sphere. Now when light enters the sphere, all of a sudden it does this crazy loop-de-loop thing. Let me see if we can follow it. Goes in here, goes around here, goes around, wait a minute, in here, there it is, around here, around there, and then it goes out. Same thing with the bottom one. It kind of loops around and does some things. So we keep going down. This one kind of evens out, and then we have the second ray come in about there. It goes through, and we have the third ray come in, fourth ray come in, fifth, sixth, seventh, eighth, and finally ninth. And then when we get to an index of 2, we're set. Let me run the visualization a little bit faster, because I think I don't know, it just boggles my mind. But everything else seems to be a physical result, and I don't know what to trust. So again, we're just going to squeak through that. Here's a drawing of the lens, and these are all the rays as they're coming in. It's just, yeah, right, Gustorn? Man, this one visualization, like, kept me up all night last night. I was just thinking about it. I couldn't, I didn't know what to do. Anyway, we get a lot to do today, but I just wanted to throw this out there because it's weird. It is weird. Anyway, that's the visualization that's currently up on GitHub. Feel free to pull it. Just run the make command and you will have access to it. Of course, if you don't know where to pull it from, we're simply pulling it from github.com/ or I'm sorry, the Simuleos directory. There's a link under my stream. Mention it in chat if you want the link to. I can give it to you there. Okay, so let me also, before getting started, let's open up Zernal and talk about what it is that we plan to do today in more detail. and then we'll go from there. So at this point, guys, we have some pretty dang cool visualizations of what are pretty simple, I would say, physical systems. That is an optical lens where light goes in, it does a whole bunch of refraction, and goes out the other side, right? In this case, of course, we've modified the refractive index. I don't know if I have a GitHub command, Gustorn, but let me think. Yes, so we've modified the refractive index as a function of r, which is a function of the radius of the lens. So, for example, we have... Shoot, that was supposed to be a circle. 1 second. Oh, come on. There we go. There's our lens. Okay, here's the center of the lens, and here is r. Okay, at any point, we have some small r here. Okay. And the idea is that we have some sort of function of r, like let's say 1 over r, or maybe error function of r, something like this. Some sort of weird function that we're dealing with that changes the interior index here. Okay, we visualize that index change, and then what we do is we send light through. We've sent 10 rays through, we've sent thousands of rays through, we've sent a bunch of different rays through. We have 3 different visualizations we run. One visualization where we just send 10 rays through and we watch them as they slowly move through the lens. That's what you see to my left. We then have another visualization where we watch as the index varies from, let me think, the index varies from 0 to 2, or from 1 to 5, or something like that. Thanks, Gustorn, I appreciate it. Now, what else do we have to do? Good. So these are the visualizations I want. We have the 10 rays going through very slowly, so we can see all of the... let me think. So we can see all of the... we can see the speed of light changing as it's going through the lens. Another one that goes through and sweeps through the entire lens, so we can just kind of watch all of the possible ways the rays can refract. And another one that sends thousands of rays through. Those are the 3 visualizations we want, and I think that's correct, Gustorn. Yeah, totally correct. Thanks a lot. I really appreciate it. Okay, so that means we have basically all the visualizations done. Now what we want to do is put in some weird sphere, I guess you could say geometry, but not really geometry. Some weird index variations on the inside, right? And we've done this before. In fact, when we started back this stream, this, I suppose, method of visualization, we did it like 6 months before or something like that. But here we have kind of resurrected it, and the very first stream we went through and checked a whole bunch of cool functions. Here we're going to do something similar again, except we're going to change the way we're doing the visualization, because right now all I'm doing to change the different functions is I'm basically commenting out old material or deleting old material, and it's kind of, it's not ideal at all. So what I'd like to do now is make it so it's easier to switch between the different lens types. And with that, I think we'll be done with the simulation, except for one thing that we have left to do. And it's kind of obvious. If you look to the left, there is one ray that's going along the top of the lens. I like that ray being there because it helps basically show that the speed of light is changing on the inside of the lens. However, I kind of want to get rid of it too because it's kind of bothersome in another respect, because it's no longer symmetric about the x-axis, you know what I mean? So it's something to think about. If you guys think we should remove the ray, let me know. I'll totally get rid of it. I mean, the point here is that eventually this is just going to turn into a YouTube video. I honestly, it's just cool. It's probably the first video I'm ever going to make that doesn't really provide that much information. It just provides really just cool physics, you know? Which is pretty neat. Okay, so I think that is about that. Let me go ahead and pop this over to the next desktop. Let me clear this terminal, and we should be good to go. I don't think there's much more that we have to discuss. I realize that was just a quick 5-minute introduction, but luckily the system we're working on, as I've said before, is, in my opinion, physically intuitive. You've got rays of light going in, refractive index is changing, which makes it so the refraction goes from there. Sorry to interrupt your physics. theories, but you need to tell me about the music you play. Oh, okay. The music I play. Yeah, I agree, Gusto, and I think that's good. The music I play is available from Josh Woodward, actually. I think I have it under my stream just because I figure people might ask. Here's info. Let me scroll down. Music, VI, auxiliary info. Music, okay. It's available here. Now, the thing is, I do speed up the music by 1.5 times. It's under Creative Commons, so you're technically allowed to do that. But basically, I just took random songs and I sped it up. And that's where I got the music from. This guy's actually pretty good. He's got a lot of good music, and I would strongly consider looking into his stuff if you're interested in this kind of music. The other thing I want to point out is, what is it? If you want, I can give you the exact playlist that I'm running. It's kind of in the background. I can send it to you via like chat or something like that later. But you got to remind me. Don't let me forget. But I can send you the exact playlist I'm running afterwards. Okay. Single rate further from the lens. Again, that is ideal. So, what are we going to do? Well, now let's go ahead and implement our little functions. So, let's go into ls. Let's see what we got. We have everything we need. Again, the make function does what we want. So, let's go into geometrical.cpp. Okay. If we go down to the bottom here, you'll kind of see... Oops, that's the print index function. You'll kind of see what I mean. So this is what I've been doing to kind of mix with the different indices and things going on, right? I've been saying, okay, we have some sort of refractive index. Here was the refractive index of what I was using before, some sort of index parameter over diff, where diff is defined as r over the lens radius. It's just kind of a mess, and I totally admit that. And I've been trying to clean up my code whenever I can. I'm just not very good at it. I mean, I think it's kind of true for people who don't have, or for people who have been not formally taught computer science, which I would argue a lot of people are not formally taught computer science. I'd argue that even people who have a computer science degree, they tend to teach themselves the programming aspect of things. But it's required to teach themselves the programming aspect of things. You know, like, it's not something you just get. You know, it's not like you can sit in a lecture and you can start to absorb how to code. You have to kind of just do the coding. Anyway, the gist that I'm looking off of is this one right here, which is, again, mostly gustoring, but, you know, there are some changes and things here and there that need to be made to make it fit the code itself. Again, in some respect, I feel kind of bad for just taking code, but I've done it before, and I'm not as ashamed as maybe I should be about it. So again, if you guys have any questions, comments, concerns, let me know. I will totally get to it as soon as I see it in chat, and let's go ahead and get started. After I get a drink of water. I'm always thirsty. Oh, by the way, guys, yesterday. Okay, so long time ago. Yeah, I'm not gonna worry about the tabs and spaces thing, but a long time ago, I used to be a swimmer, right? So I used to swim all the time. It's okay, Gaston, don't worry about it. So yeah, used to be a swimmer when I was younger. Used to swim all the time. I haven't done it in a very long time. Rather, I've started doing it again once a week on Monday nights, which was last night. And last night, I came back to swim. I went back to swim again, and my friend wasn't there with me, so I just swam, you know? And I did a 4,000 individual medley, so that was 1,000 butterfly, 1,000 backstroke, 1,000 breaststroke, 1,000 freestyle. No, I had to take breaks at the 1,000 mark, so it was kind of like mod 1,000, you know, I would drink water. But outside of that, you know, I did 4,200 yards, and I was pretty proud of that. I don't know why I said that, but I was super proud of it. Okay, so let's take a look at our sphere struct, which should be in geometrical.h. Let's go over here, vi geometrical.h, and let me see what we need to add here. So where is our sphere struct? Struct array, struct simple, struct sphere. Okay, so we have double radius, vector origin, double index parameter of 1.0 to start, and then we have sphere, radius, double x, and double y. Now, let me see what we have here. inside of normal at, refractive index at. These are all exterior functions that are not within the struct sphere. So let me see. How do we call these functions over here in in our code? It looks to me. Let me see. We have refractive index at, and these guys are all. They all read in some sort of lens, right? So if we're reading in a spherical lens, which is the circular lens that we're typically working with. Also, Granotepple, don't worry at all about interrupting. I get interrupted all the time. But yeah, it's I have a lot of info down there, so it's kind of hard to traverse the large number of information. Okay, so we have, let's see, refractive index at. So basically the idea is that we want to absorb this function into the spherical lens. Yeah, I'm just trying to think about how we need to change the code. So let me go up and let me check refractive index. Oh, 1 second. Index at. I think this is only called once, and I think it is called, let me see. Yeah, right here. It is also called later on, though, with the optics visualization. So let me check that one too. So here we were already reading in the lens, so that's fine. And we're reading in also the sweep ray P, which is going to be the ray that we're currently asking where is it inside of the lens. So basically, if we have 10 rays, we're picking one of the rays and we're saying where is this in the lens. Okay, let's write and quit, and let's go into opticsvisualization.cbp. Let's also check that one, refractive index at. Okay, so this is again called for index texture, but I think index of refraction. What is this one called? Is this another index plot? Yeah, okay. So it's either called in this index plot function. Sorry. Or the other one. What kind of bird is always fighting with the police? Sagi? Refractive index, that should just work. We can see, but I've got a feeling. Let me see. So if we put it into... sorry about that. Double refractive index at vector P. If it's a member function of... let me think. If it's a member function of the struct sphere, right? Then... Anyway, it's fine. It doesn't really matter that much. I'm just kind of checking it out before making the final decision here. Okay, so let's go ahead and modify our sphere struct. The idea is that in addition to having the radius, the double x and double y, we also have an additional what is called index function over here. So let's go ahead and add that in. And the index function is basically here. Let's go over here. Yeah, it is a member function of this one, so we'd have to modify some things, and that's what I'm trying to decide. Should we keep the member functions or not? That's kind of the question. But anyway, it's a template up here, if you can see, with capital T. So basically, we're turning struct sphere into a template and a whole bunch of other things. So I think that's a good idea. Let's go ahead and get started with that. So here we're going to say template. Let me see. I always forget how to do templates. Template type name T. 1 second. Type name T. Good. And now we're going to go down here and we're going to say index function. I'm sorry, T index function. Okay. And we're going to keep the notation as the gist. And if you guys want, here, I'm going to give you guys access to this too, so that everyone can kind of look at it. I mean, because I'll be hopping back and forth. So just in case I do something or you miss something as I'm hopping back and forth, this will allow you to see it there. Okay. So then all we have to do is add it over here to the initialization where we have double x, double y, and also t function. And I think we need an ampersand before that. Let me check. Is that correct notation? He did constant t, which I suppose is fair. Okay. Now let's pop this down here. I don't know where I'm spacing it, but hey, whatever. Then at the end we read in index function. Okay. Let me think. I think Is that correct? Oh, we need index function of function, obviously. That is me failing miserably at, what are we calling it? 1 second, let me think. Initialization. What is it called? It's not initialization. It's, I don't remember what it's called, actually. No idea. Okay, so now we're reading this in with the index function. So, every time we initialize it... Wait, you want me to remove index parameter from the sphere? Let me think. Refractive index at... Okay, let me think. So, basically we need the index parameter for, well, most of these guys. So let me think. We're reading in double operator. Let me see. So, what you're saying, let me see. So we have these guys as member functions, normal at, contains, refractive index at. That's fine. And honestly, I think I might leave them outside of, I might leave them just, let me see. Return index function, this, p. Yeah, it should be okay. I think it should be okay. Refractive index at. Let's see, return dot, origin p, radius times radius. Okay, so we have make sphere, which again is probably something we need. Now let me see. Constant index. We're gonna say we read it in with an index I, and then we have a double operator, sphere, constant index, and vector. The thing is, we need the index parameter for basically all of these structs, except for invisible index. Every other one's gonna have an index parameter associated with it, so we can make plots kind of like the error function before. So in the end, I don't know, we'll have to see. But again, I'm just gonna kind of go through this and implement it line by line until we get everything kind of set. So what I might do, just so I don't have to keep hopping back and forth, is I might just pop this over here, something like this, and make it the size of this terminal over here, so everyone can kind of see what it is I'm looking at and stuff like that. Good. So let's go ahead, open up this terminal over here. Right quit. Right quit. Open up this page, and now let's go into geometrical.h. Yeah, this is probably a little bit cleaner. Again, I know my face is covering the lower part of this particular, what do you call it? Web page. But that's okay, we'll get to it. So let's go back down to the sphere. Okay. If you need it in multiple ones, keep it in sphere. There are better ways to do it, but I don't want to modify the just now. No, that's fine. Okay. So we've already read in the initialization guy. Again, I can't see constructor. I don't know why I couldn't think of that. Okay, so now what's next? Well, what's next is we could move the normal at, contains, and refractive index at inside of sphere, and I think that's fair enough. So let's go ahead and do that. We're gonna say vector normal at vector p, which is the position of the ray that we're reading in, constant. Okay, and let's see what we got here. Return normalize of p minus origin, and we have an origin already in origin. Good. Then, oh, I wrote r instead of p. Sorry about that. Okay, so now that one's done. And again, the reason we need normal at is because with, let's say, Snell's law, which is the law that we're using to basically tell how far the light is refracted, we need to know the normal at any given point in time. So this gives us that normal. Okay, so now we Boolean contains, which I'm actually not sure what that one does. Do we have that somewhere else? We do not. So let me see. Contains is going to be dot product. Oh, you're asking whether it's within the sphere. What do we have? What did we say? It's fine. This will work. Contains. And we see vector p. Good. And we do constant. Okay. By the way, 4 years of using Vim, or VI, I suppose, just found out about capital O. Holy crap, just changes your life when you find that out. So, 1 second. We're going to say return dot of origin and P, and then less than radius times radius. Radius times radius. Okay. And now the last member function that we're going to work with is here, and it's going to be double refractive index at. And what we need to read in is vector P, which again, position of the ray. There we go there, capital O. And then we're going to say if contains P, which is fair enough. We're going to then go here and say return. 1 second, return index function. 1 second, index function. This and then P. Good. Add in a semicolon. Now we have an else after that. And to return 1.0. And actually, yeah, it should return 1.0. I think that the expression for contains is a little bit off. I think it's right, but let's check. So return 1.0. It's the same as the inside of function, right? So let's go into geometrical.cpp and let's go to inside of, here it is, return p of x less than lens left, lens right. Oh, wrong inside of function. Here it is. Double diff is equal to distance of lens p. Okay, so I think let's calculate distance. Where's that? Distance. Here. Where's the other one? Distance there. Oh, I know where it is. It's going to be in vi geometrical.h. And then we go to distance. Here it is. Okay, distance is going to be basically the length of a minus b, which is going to be the dot product. Wait. Yeah, actually you're right. In fact, let's just change this back to the other function that we had before. It's right and quick. Geometrical.cpp inside of. Here it is. Let's do this one. Here. Yeah. Oh, this one, sorry. Double diff is going to be equal to distance between lens.origin and P. Okay, and let's go through and check that one. Wait, keep it with the dot? Dot product of the difference with itself. Yeah. Let me think. So what we need to do is define... Yes, so we need to find an x and a y. So we'll subtract one from the other and then do the dot product. Wait, should be x squared and y squared, right? Square root of x squared plus y squared. That's what we're looking for here. So let's go ahead, go here, right quick. Go into geometrical.h, go down to contains. Good. Now, what do we want? We want to do dot product, and let me see. Because there's definitely a way to square something. Return length. Vector d is equal origin.p. Can we just do dot dot? Well, let me see. Operator. Vec normalize. Double distance is null dot. Sure. That'll be the easiest way to do it. So here's contains. Here it is. So we want to do this. It returns a boolean. Oh, I see. Yep, that's what we want. So we're going to say return. Yeah, so we'll say vector d, exactly what Edison has over there, equals origin minus position. And then we're going to return dot of dd. That's fine. D. Okay. And that'll do it. Good. Okay, so let's write that. So we have all those functions down. Now let's go ahead and create the next one, which is make sphere. Now this guy, as you'll see down here when it's used, is going to be basically used to create the sphere that we want with the appropriate index function. Now I'm going to leave the index parameter in the struct sphere for now, because I've got a feeling we're probably going to need it in a bit. Or rather, we might need to use it in a bit, but no time to squabble about that. Let's go through and let's keep working on this. So the next thing we need to add, let's see, we have our simple structs. I guess this is probably the best place to do it. Well, no. Do I have functions down below? Let's see. Inside of normal at. Yeah, this is a good place to do it. So we're going to say template function to create our sphere. Or, sphere lens. Good, so now we're going to say template, type name t. 1 second. Also, your Japanese pun yesterday was pretty good. I was really just out of it. I remembered it today and immediately clicked. I'm sorry, guys. I wish I knew more Japanese, but I don't. Sphere of t, and we say make sphere. Then we say vector O. Wait, O must be the origin. Yeah, let me change this so it's vector origin, vector radius, or double radius, sorry about that. Constant t function. Constant t ampersand function. That was Finn. I wanted function. Okay. Now we're going to return a sphere of t. Then we're going to with origin, radius, and function. Okay, so now we just have to add in all the structs for all the indices and manipulate our code so it works. Again, guys, this is just a matter of making the code a little bit easier to read and understand. It's basically, how do I put this? It is, yeah, it's basically exactly that. Frank, how do you calculate the yaw and pitch with the XYZ coordinates? Let me think. So if you have, okay, that's actually easy. Just mix, switch to cylindrical coordinates, not cylindrical coordinates. Switch to spherical coordinates, and then you can do the yaw and pitch with these. Yaw, I don't remember which is which. One is this way, one is this way, right? So let me think. I guess pitch would be this way, and yaw would be this way. I don't remember. Wait, my constructor is different? Let me see. Maybe I did something stupid. Return sphere. Oh, yeah. You're right. You just read in to the constructor. Yeah, fair enough. Sorry about that. I wasn't thinking. Double R here. Let's see. Vector origin. So we want vector origin. Yeah, let's do vector origin. And then we want double radius. Hey, Slayer Darth, what's up? Let me see. Yes, Slayer Darth, what is your question? So we're going to say origin as a function of origin. And then we say radius. Oh, sorry about that. Here. Okay, so that should be okay. I think everything else is set. Sure. Yeah, good enough. Okay, so what's next? Next, we have to actually start creating the individual functions on the inside. For your next visualization, calculate the pitch. For your next, I'm sick and tired of watching Pluralsight. What is Pluralsight? I actually don't know what that is. Sorry about that. Feel free to post a link and we can take a look at it. Okay, so let's go ahead and create the first one, which is in some sense the easiest one. So struct. And let me just kind of put here structs for all lenses. Okay, now we're going to say struct constant index. Fine. Index. And what are we going to say here? Here and there. Quick Vim tip: to change the current word from cursor to CW in normal mode. Yes. I somewhere in the back of my head I knew that. Let me see. I'm looking to apply for computer science sometime next year or the year after in 2018. So I want to get some GitHub projects started so I can use them as a dedicated as dedication to the subject. Could you maybe email a list of sometime of only resources you use and maybe give me some recommendations for starter projects? So this is actually a super good question, Slayer Darth, because a number of times, it's weird. In my opinion, actively contributing to the open source community is essential, at least in my opinion, to bettering your understanding of programming in general. Again, my opinion. That said, for me, because I'm a physicist, there isn't really that much for me to do, right? The open source projects are not usually open source physics projects. It's as far as using Vim is concerned, just you do you. I'm not going to force anyone to use a text editor they don't want. So what else do I want to say? So in terms of finding an open source project, I think other people in the chat may be better at helping you out with that. And Frank, you're right. Open source does not necessarily pay. However, there are a lot of companies that will pay you to do open source development, unless it's for certain tasks that a huge learning curve is required. Let me see. I heard it's got a huge learning curve Vim, but I found it fine so far. Yeah, so it depends. So the thing is, you have to think differently when you're using Vim or VI than you have to think when you're using any other text editor. Now, maybe Emacs also has a bit of a different thought process to it, but the nice thing about Vim is just how lightweight it is and how quick it is to do everything. So that's kind of why I like it. And again, I switched between Vim and VI. For this stream, I use exclusively VI, but at work, I've been using Vim, and it's tempting. It's tempting. But as far as open source projects are concerned, if people have if people have ideas of good open source projects, feel free to post them in chat, because that's something people totally could learn from. And I'm hoping that people learn a lot. Basically, every time they come to this channel, I want them to learn something, even if it's not that great. Everything isn't a shiny rainbow. Open source was big a few years ago until all of those devs starved from hunger because they couldn't buy food. So you're right, Frank. You are bringing up a very good point, and that is that open source software is inherently, you don't buy open source software, However, there is some utility to it. For example, some projects like OpenMPI and OpenMP, you can totally be, your job can totally be writing that type of software, and it makes sense. The open source community makes sense for certain people. For example, let's say Microsoft and Apple, those are kind of big companies, but let's say two smaller companies, of which will remain unnamed, want to work on some software project, but they don't necessarily have the time to devote all of their development staff towards working on this project. They could take an open source project, and one company could work on it, and another company could work on it, and then working on it together, hey, they've got better software that happens to be open. And again, as Gustrom pointed out, Mozilla, Android, these people have companies. These people have open source software all over the place. Gustron Incorporated, it'll pay someday. Okay, so what am I doing next? Let's go down here and let's see. So, struct for simple lens. Okay, we have the constant index here, and basically I want to modify how this is currently running. So, does the company customer... Yeah, actually it was kind of weird. When I was talking to my advisor the other day about what I'm going to do in the future, with my life and stuff, which in hindsight, maybe I shouldn't have asked, but I thought it was good to talk to him about what he thought future careers in research are and things like that. Anyway, he said you've got basically two options. You've got either go for a postdoc or work for someone in my lab who was going to open up a company that ruled the world someday. And I was like, great. Okay. Okay, so let's keep working on it. Double index is what we're going to need. Double index. Money's overrated. Just printed paper. Well, it's not just, it's also some sort of cloth type of thing. I look up to Gustron, really motivated, and helps me in my linear algebra endeavors. Gustron, quite frankly, is a super helpful person. And I don't think this channel would be anywhere near as far as it is without Gustron. I publish very few of my projects on GitHub because I don't feel like the code's up to par. My code's never up to par. Okay, so what do we do? Constant index. Index. And we are reading in a double. I, for index, is going to be index of I. Good. Add in a semicolon if I can figure this out. Actually, wait. There we go. That's our constructor. Now we say double operator. And we're going to say sphere of constant index. Ampersand and vector. Okay. And we say return index. Done is done. Look at that, guys. The staff is a joke. I don't know which staff you're talking about, but hey, that's okay. Slate Earth, not even that. It's fabric. Good. Okay, so what's next? We have to make sure there's a semicolon at the end here because I've been failing to do that here and there. Semicolon there. And a semicolon there. Now, this notation is kind of weird, but just take time to think about it and you can kind of absorb what it means. Again, you're talking about someone who was basically using standard C98, C99, whatever, the C for the longest time. And only really recently switched to C++. Basically, all my C++ code was... See, that's the thing. I don't know if Frank's being passive-aggressive. Honestly, he might just be... I think it's fine. I have no idea. I mean, we'll see. I think he was just being... Okay, well, now he's trolling. Okay, so now we're going to say struct... for the next one, which is going to be the inverse ERF index. Okay. So after we implement this one, actually, wait. We already have the constant index. Let's go through and let's do it. Let's just check out these. Let's just use the constant index function. Since we have it, let's use it. So now we have, and this is actually quite nice, we have all of the things we need already within the struct sphere. So we'll create the struct sphere, we already have the refractive index, that function, everything else is set, so let's just modify our propagate function accordingly. Right quit. Hey, Nasimiko, thanks for coming in. So we're going to say geometrical optics.cpp, and what we want to do now is implement just the static constant index. But first what I want to do is open up the other terminal over here, and I want to run the make command. Okay, so we've got a lot of issues here. Let's go ahead and see what the issues are. So sphere is not a template. Okay, so geometrical.h76. A site in which I want name Twitch band. Wait. Well, I'm not sure exactly why. But I will... I don't know. Twitch... I'm ambivalent to Twitch. Sometimes I really appreciate the service that they're providing because this is really the only place where I could be doing what I'm doing right now. I really appreciate that. Every once in a while they make decisions that I don't appreciate though. And I try to talk about those when I can. Twitch want to enlist a democracy fist? A democracy fist? Over the internet? What? What is a democracy fist? Everyone votes to be punched? Okay, so let's go through here and let's fix this up. So, note previous declaration here. So, what do we need to do? Geometrical.h 76. Okay, struct sphere. Sphere is not a template struct. Oh, maybe it's because we're using sphere elsewhere. Wait, they banned you too, Nasimiko? I didn't know that. I've got a feeling there's something up. I don't know if I'm allowed to ask, but I certainly would not like to be banned off of this site. I mean, I use this site all the time, literally every day. So I'm hoping that nothing happens. Maybe, so it used to be a while ago that they would ban people, let me see, that they would ban programmers specifically for non-gaming content. And once the programming community was kind of established in Twitch, I think that kind of stopped happening. However, I'm not sure. Maybe my stream's still considered non-gaming content, but that's fine. I just had one of the staff members on the phone. They say you're next. Me or Gus Torin. Either way, it's fine. If that happens, again, there are other streaming services we could use, and I would do my best to get in contact with you guys, and or the ones that I can, and basically tell you guys where I would go from there. But I really don't think I'll be banned from this site. It'd be bizarre if that happened. Okay, let me see. What do we have here? So what we need to do is modify all of the functions with sphere in it to take into account the new template that is sphere. So let's go through and check the error messages. So let me pop this over to that desktop and let's see what we got. So the first error message is sphere is not a template. Okay, so what I might do, which I will admit is a little bit hazy, what I might do, I've already written in passive-aggressive emails, a lot of passive-aggressive emails, so, but it was about something else. It was about back when Twitch incorporated programming with into creative. That was when I sent them a bunch of emails. I think I sent them 3 or 4 at the time, but I only had one point of contact, so it wasn't really that easy to do. But again, that's fine. You should remove the old ones. Yeah, so let me check to see what we have. So the first one is geometrical.h76, and it says sphere is not a template, included from geometrical.cpp 20. Okay, so it looks like constant struct sphere lens. Let me see what that one is. Optics visualization.h, vi optics visualization.h, and what do we have here? We want to go to 83. Okay, so this is something we're going to have to think about. We have to read in the sphere. Let's see, sphere is not a template. Let me see, how do we fix this? Info included from geometrical.cpp 20. Note previous declaration here. Constant struct sphere lens. Okay, so we need to read this in as a template. Let me see, how do we do that? Again, I'm really bad with templates, guys, so forgive me if I'm doing something stupid. Nasimico, I am currently using Arch Linux with the OpenBox Windows Manager. I got this email from... Thanks, Frank. So, your account was indefinitely suspended of using your chat system to spam or distribute malicious content. Huh. Interesting. Your IQ needs to be above 150, though. Sure. My IQ is definitely above 50. Okay, so what are we going to do? General Soak, why do you need the sphere to be a template? So the reason we want sphere to be a template, let me go ahead and open up that code again. Geometrical.h, and this is actually a very good idea in my opinion. Sphere. What we're doing here is we are reading in the sphere. We'll have some sort of weird index function on the inside. So for example, in the sphere over to my left, we have some sort of inverse error function, right? And so this way the sphere has the function already inbuilt. You need to have the template definitions in headers and not in the CPP files. Something to watch out for. Static dispatch on refractive indices. Okay, you need to have the template definitions in headers and not in CPP files. So the template definitions are definitely right now, or the only template definitions I have are in the header files. Here. So let me think. This first error is still kind of bugging me and I'm not sure exactly how to fix it. But anyway, the template allows us to read in the different refractive index functions, which is nice. Besides, I need to get better at programming, so this is one of those things that templates always boggle my mind and I have to kind of work through them. So, sphere, template, make sphere. Error, sphere is not a template. Oh, these are all the same. Struct sphere is incomplete. Sphere is not a template. Sphere is not a template. They're all saying sphere is not a template. Constant was not declared in the scope. Oh, well that's one. 115. Because they are const. If they're local to that CPP, sure. Let me see. Error expected before index. Sphere lens has a initializer, but incomplete type. Fair enough. So let me see. 52 and geometrical.cpp. Okay. So we want then. Yeah, I'm sorry. You're right. It is constant underscore index. Underscore index. Thanks a lot. Sphere template. Okay. So let me think. What we're gonna have to do here then. Constant index. Yeah. Let's do it. So what we need then is up here, right and quit. Optics visualization.h. Let's go down to where we have sphere here. And let's read in constant index here and see if that does it. Draw lens. Oh, maybe it's just this. And let's make that. By the way, not CPP. Sorry for the off topic again. I don't know. I've always CPP, but lately I've been seeing CC a lot. Also, instructor is superfluous when you use uniform when you can use a uniform initialization. Wait, what do you mean, Zadison? Okay. So let me see what we got here. Let me clear a couple times. Now let me run it one more time. Make. Okay. And let's see what we got here. Sphere is not a class type. Class template. Uniform initialization isn't very good. I don't even know what it is. So let me see. Sphere is not a template. Struct sphere. Wait, why is sphere not a template? Geometrical.h 76. Error sphere is not a template. It says it's defined there. Sphere is not a class template. Let me see. So what if I just read in constant index here? Let's go over here and clear. Oh, clear. And let's make it. Okay, so this is probably going to give us the same error as before. Sphere is not a class template. Yep, that's what it says. Constant struct sphere. Not many, pretty rarely go there. Constant index was not declared in the scope. Okay. What do I need to do here to get this to work? We basically need to read in this template function, this structure, this template structure lens in. How do we do that? I mean, okay. So we have constant structure sphere. Okay, so you want me to do this then. So we're going to say, oh, you, here. I see. I'm sorry, guys. Again, I'm very bad with templates. Forgive me. Forgive me for being bad at everything. Template, and we're going to say type name, T, okay? And then what we're going to do is go down here and we're going to say T. Let's see if that fixes that one error that we had before. Clear, clear, make. Okay, let's see. What's the issue here? Sphere is not a class template. Dang it. 1 second. Let me write this again and let me make sure I didn't make. Okay, now let's see what we have. No, sphere is still not a class template. So let me see if I do this. Clear, clear. Again, guys, I kind of struck sphere, not a template. Dang it. Okay. You need forward declaration. Can you use templates on structs? I mean, I think so. So let's see. I mean, everyone uses them on classes. So you need the template to allow your index functions to have different return types. Kind of. It's more like the index itself varies based on a particular function. So because they basically are the same except for that function, we basically need to have a template so that we can have a whole bunch of different functions available. Remove the struct from the function prototype. Wait, what? Also remove struct in the function prototype. Let me see. So you're saying do this? Remove the struct from the function prototype. No, you don't. 1 second. Yeah, you're right, Gastorn. Okay, wait. I'm actually a little bit confused here. You can have points. Remove the struct. So you just want me to remove this guy right here? Would that do it? Let's go here and make. Sphere does not name a type. or inheritance. Yeah, so we could do have pointers to functions. In fact, that's how I would naturally do things. However, I wanted to try. It was there for convenience to avoid for a full for declaration, but now you need to specify the sphere as a class type. Dynamic dispatch where you don't need any. Guys, all I need is to figure out how to read a temp. Fine, I will Google this because I can't figure it out. Okay, so let's go here. Googling it. Reading a template into a function. C++. Let's see. All I need to do is figure this out. So template C++ FAQ. I just need the 1 second. Template T, void function F, include string template T, T, X. Okay. So what do we need then? We need this then. So let's see if we do this. Something like this maybe? Clear, 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 make. Nope. Okay, I have no idea what the notation is here. Absolutely none. So, template X, that's not what I want. Constant TX, nope. C above, remove struct. I don't know what you mean by C above, Zadison. I'm not sure I'm following. So let me see, constant int, string, not sure guys. You need to add template type name, struct sphere. Oh. Okay, so you want... Okay. So we want template... struct. This. Expected identifier before template. I'm super confused. To the top of the header? What? But we're already reading in the other header. Why would it have to read in... Oh, are we not reading in the other header? Oh. Not in the function prototype? No, before it? Okay, so somewhere in here, I guess? So, template. Okay, let's go down here. Okay, so then we say, where are we? Draw lens, template T, struct sphere. What we want to do, you said constant sphere. Make clear. Make again. Okay, let's see what we have. Invalid use of template name sphere without an argument list. So we want sphere of T. What? Of T. Let's see that. Make. Clear. Clear. Sorry guys, this is probably super frustrating for people watching. I invalid use of type name sphere without an argument list. Dag nabbit. This is a pain in the butt. So I've only used templates before, once or twice before on this stream. Let me see. Invalid use of template name sphere without argument list. Oh, but this is for create index texture. Okay. Oh no, that's what we're currently on. Constant sphere lens, index plot, draw lens. Oh, what? 1 second, let me think. No, we're on draw lens. This is for create index texture, which is something else. Okay, wait, maybe 6. Let me see. Where's create index texture? Here it is. And we want constant sphere T lens. Clear. Okay, we're gonna do make Oh, this needs to be a template now. So we're going to say, oops, my bad. We're going to say template, type name. Right, this go here. Let's try clearing that. Make. Okay, let's see. Did that fix that issue? And values of type name sphere in object visualization at H, but it looks like a different place. So let's go to 94. Okay. Good. Okay, so this seems to be working. Thanks, guys. Sorry about being so frustrated. Sorry about that being so frustrating before. Again, I'm bad with templates. Okay, so now we have to go down here and say constant sphere T. Lens. And that should be okay. Do your index functions return different things? The index functions, I mean, at different positions, they will return different things, right? So they always return a double. Yeah, so let's see. Let's go down here. Index plot. And let me see. This one also needs to be changed. So let's do template type name T. And we're going to go down here and say sphere T. Okay. No, what else did I do? I did something wrong up here. Constant sphere T. Where is it? I'm not sure. And let's go down here. Template. Type name T. We'll go down here and read in a T. Okay. Let's write this, go over here, clear a couple times, and make. Okay, so now let's see what the errors are now. And I'll use the type name sphere without an argument list. Boolean inside of. Okay, you just replace it with double and remove the template. No, yeah, we certainly cannot. Not in this case. So we need the struct sphere, and we also need at least some way to identify which functions are in we're using in the sphere itself. So in this case, I do agree the template is the right way to go. Okay, so geometrical.h. Oh, that was a mistype. Yep. Right, quit. So we're finally back to geometrical.h. I apologize for this being so frustrating for so many of you guys, but that's how it goes sometimes. I just don't know. You know, here's the thing. When it comes to programming, there's a whole bunch of freaking complicated stuff, and a whole bunch of stuff that's not so complicated. And you can choose to do things in a way that is complicated, or a way that's not complicated. We could have done this in a way that was a little bit less complicated for me, but would have been a little bit harder to read in the end. So it's kind of a different thing. Yeah, and I totally agree. A template is a good way to do this. I just, again, I'm really bad with templates. So let's go ahead and update all the functions that use sphere. Sphere is there. Sphere is here, but it's inside the struct. Should be fine. Okay, good. So here, constant index. Good. Inside of. You know what I might do, guys? Because we already have inside of in sphere, I'm going to go ahead and comment this out. In fact, because it's already on GitHub, I'm just going to go ahead and get rid of it. Next. 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 Okay. Let's read this. And let's go ahead and clear a couple times. Now let's make it one more time. Okay. What do we have here? Error, missing template arguments for lens. Okay. So we're in geometrical.cpp now. So let's see what happens if we do go into geometrical.cpp and we modify that code. Okay. For some reason, I feel like I missed a lot of functions. Why do I feel that way? I get that you want to have different functions and then construct different spheres with them. Yeah, General Soak, I see what you're saying, and I do agree. There is a way to do that without templates. But in the end, here's what we want. Let me pull this over here, pop it over there, and bring this here. Okay, and here. We're going to have a whole bunch of different guys here. So we're going to have inverse error function, invisible lens, constant index, a whole bunch of stuff like that. In fact, we're going to have tens of these. Dozens of these. Unless you also need the index function to have different return types. No, I honestly agree with this. I think this is a good way to do it. For now, We'll see. Worst comes to worst, if it isn't a good way to do it, we have the old code available on GitHub, so we can just pull that. Not that big of a deal. Okay. So what are we doing here? We are updating the... Oh, what did I do? Okay. We're updating the code. So missing template arguments before lens. So what are we going to do here? Let's go to 52. Okay. Let me see if I can get this right. Okay, this being function pointers and templates is that you introduce the next level of indirection where you don't need any. Lens here. Okay, I think that's the right place to put it. Lens was not declared in the scope. Should be now. Invalid inside of. Error. Invalid geometrical.cpp. Okay, so now let's go down there. Where do we do these? 325. Okay, and if we have a constant sphere lens, oh, these are now deleted, aren't they? Let's go down to sphere. Circle sphere normal at. Also deleted. Good. Next. Circle sphere refractive index at constant sphere lens P. Okay. This guy is... I'm going to leave him in there, but I'm going to comment him out. Oh, It's on GitHub. I'll grab it if I need it. I know this is like the worst way to do things, but that's how I'm doing it. Okay, so now every time we do inside of, what we need to do is change that. So let's go to inside of, which should be used a few times. There's inside of, return inside of. Wait, what? It's only used twice? Propagate mod. Let's go to refractive index at, which should be used. Here's there, here it is there. So what we want to do now is we move to N2 is going to be the lens dot refractive index at and then sweep ray B. This should be just for a sphere. Let me go up and check. We say constant T lens, but it really should just be for a sphere. Let's see, what's the next one? Refractive index at. Good, so now we're going to say lens dot refractive index at. Okay, we're probably going to have to modify this, let's see, both of these guys, so that they don't read in arbitrary lenses, which is a little bit unfortunate, but that's okay. Let's go ahead and right here, go here, and let's make. Actually, let me clear a couple times again. And again, I could be using Control L, but I just, for some reason, typing in clear happens. Okay, so let's go to 52 again, because we changed the constructor. So let's say we want lens P, which is the lens position. Then we want radius. And then we want, I guess, constant index. Let me go over here. Regular function pointers might not even work because some index functions might need internal state later on. So the only alternative is STD function, which would be easier to write but slower. Okay, let me go over here. Let me make sure I'm calling these guys right. Make sphere auto S1. Oh, you're just using auto. It's okay. Okay. Wait, constant. 1 second. Constant index, constant. Oh, I see. You're right. We have a make sphere function. Okay. And I'm going to modify the make sphere function in a bit. So we have sphere template. 1 second, let me think. Sphere, make sphere, vector O, double R, constant T function. Okay, so we want the make sphere. Let me think here. Yeah, this will be okay. It's not quite Sonic music, but that's okay. So what are we going to do? Let's go ahead and comment this out for now. Now we're going to say, ooh, that was not what I meant to do. We're going to say, fine, we'll use auto. Lens is going to be equal to make lens with the following characteristics. It should be lens P, radius, and of course constant index. Good. Let's write that. Let's go over here, clear a couple times. That's fair enough. And let's make. Okay, int main, expected primary expression before make lens. Make lens is not declared. What did I call it? vi geometrical.h. Let's go down to make lens. That wasn't found. What was it called then? Make sphere. Okay, sphere. Write this, go over here, right quit, and make that. Expected primary expression before... What do you mean? Make sphere, auto lens. Expected primary expression before. So, what does that mean? We draw lens, layer 1, that doesn't matter. We're at auto lens, right here. And it says we're expecting a primary expression before, which typically means I forgot a semicolon. But here, it doesn't seem to mean that. So let's open up geometrical.h. Let's go down to make sphere. And let's see what we got. Sphere. Oh. But we're using auto, so that should be okay. Let's take a look at what we got over here. Auto S1 is equal to make sphere. Oh, no, we already defined that. Where did we define lens position? Yep, lens position should be okay. Auto lens equals make sphere, lens p radius constant index. So where would this error be coming from? Right quit? Did I use mismatched parentheses? No. Expected primary expression before. Oh, you know what? Maybe it's because I didn't define what constant index was. Okay, so let me think then. We want to do that. So let's define what this means. So let me go here and let's define the lens. So we're gonna go here and say constant index. Constant equals, for now, 1.4. Let's write that, go over here, let's make that. Okay, so it looks like we're kind of sort of getting there. Got a couple more errors to fix, but you know, we're getting there. We're getting there. So let's go ahead and clear a couple times. Okay, and now let's make that. Okay, what do we have here? 56 required from here. In instantiation of light array. Let me see. Required from here. Passing constant sphere index as this. Argument disqualifiers. Raise I. Lens refractive index at. Wait. Okay. Let's just fix a whole bunch of the errors that we can fix, and then we'll go from there. Invalid initialization. So let me see. 144. Definitely something we can fix there. This will be lens. Dot refractive index at. I thought I fixed this before, but for some reason, maybe I didn't. Then vector and normal at. So 148. Equals lens. Dot normal at. That is what we called it, isn't it? Hop over here. Normal at. Yep. Okay. Let's go ahead and write that. What else do we have? Now we've got to fix these. Origin will be initialized after. Double sphere, double radius, initialize sphere. Okay. Passing constant sphere, constant index as this. Argument required discards qualifiers. I don't know what that means. But it's okay, we'll kind of figure it out. Incall double sphere, template parameter 1, double refractive index at vector p. So that was fixed. Let's go ahead and just run this again with after fixing those errors. Clear a couple times, and let's make it now. Okay, so it's a significantly shorter list of problems. 144, constant sphere as this. Refractive index at. Both of these guys are from refractive index at because that's the one where we pass things as star this. So, what is the error then? Passing constant sphere, constant index as this. Sorry about the chat, guys. Every once in a while, it just disconnects and reconnects. If I missed one of your posts, just repost it. You'll see what I see on screen. So let's see, constant sphere, constant index as this. So lens.refractive index at radius IP discards qualifiers. Okay, so let's take a look. No. Right click. Go into geometrical.h. Scroll down to sphere. Here. So this is what we got. Double radius. This is the guy that's having trouble. So this. That means we have to read something. Yeah. Yeah, so let's think. Refractive function, this P. Okay. So let's go into vi geometrical.cpp and let's think refractive index at. Good. So I'm only reading in one argument, which is what we should be reading in. Vector P. Okay. So if contains P, so if we're within the sphere, otherwise we return 1. That's great. So now we say return index function for this and P. Where is index function? That's going to be defined as, in this case, constant index. So then we go down to constant index, and it's having a problem using this guy, which again is not something I use very frequently. I don't use this a lot. The functors are missing it too. The functors? Man, every once in a while I step into a world of computer science that I know nothing about, and it's kind of annoying, but that's okay. I know this is like right in my periphery. It's like, it's right there. It's just something I can't quite figure out. Okay, so refractive index at is pulling just the vector P. That's good. Index function. Okay. Mixed sphere should be fine. Constant index should be okay. So then, oh, I see. That's kind of clever. Okay. So, check the gist for the constant you missed. I compiled that. I don't think I missed anything. Let's pop this back over here, but I'm fairly certain this is exactly what you wrote. Return index, this P, else return 1. A double refractive index at vector P. What are you saying I missed? Constant index function, normal at constant, contains constant refractive index at. Let's see. Constant index, double index, constant index, I operator, sphere, constant index vector. Wait, where's the mix? I don't see the missing const. Sorry about that. Refractive index at. Refractive index at should be a const. Let me see. Double refractive index at. Oh, so you want me to put a const here. Let's see. Okay, see if that runs. Okay, let's go ahead and rate this. Make that. Okay, well, it seemed to have a different error. Will be initialized here. Okay. Index function was not declared in this scope. Okay. So geometrical.h96. I need to update the functors. I don't know what a functor is. So let me see. Constant function, refractive index at, return index function, take in sphere. Oh, functors are the index structs. Okay, good. So in fact, this can't be a constant. You're right. So then, make sphere. I want this to be not a constant. Okay. Make error passing constant sphere as this. Really? Because then I'm screwed. I think it needs to be not a constant, because I need to read in the index parameter. Yeah, I definitely need to read in the index parameter. So how am I going to change it then? Because I don't want there to be constants. You see what I'm saying? So in the end, I need to multiply it by some factor, which is that index parameter, right? So let me think. Return sphere origin. Constant sphere as this. Okay. Let's go up here and let's do constant. Okay, so I'm not sure then what the problem was. So let's go down here, add a constant here. Okay, let's go here, let's make it. Oh, what did I do wrong this time? Error semicolon at the end of member function. Refractive index at... Oh, shoot, I did this one backwards. Sorry about that. Yep, thanks, Addison. Sorry about that. Okay, let's see. Change the constant index operator to just take a constant. Constant index. Double sphere. Let me see. Where am I defining make sphere as a... I don't think I'm defining it as a... One second, let me see. Constant index double I, index I, double operator sphere, constant index vector. You say change the constant index operator to take a constant sphere. Okay, wait. So the operator here... Oh, so you want this to be constant. Make index function is not declared in the scope. Okay. So index function is not declared in this scope. Let me see. Index function is defined as a template. Let me see. Required from here. Okay, and then we have to figure out what the heck is up with these warnings, because I don't know what those warnings mean. But we can probably fix those in a bit. So let's see. Oh, did I? How do you have it in the gist so I don't get confused? Okay, let me see. What did you call it? Index underscore function. Fine. Let's do it that way. So let me just do a search and replace to make sure I didn't screw up again. Search, index function, index function, G. Okay. Write this, go over here, make that. Okay, in the constructor initialization list, you're initializing origin before radius, even though origin is defined before. So this is still broken. Error no match call for constant, constant index, constant sphere. Okay, that's fair enough. As a rule of thumb, you should initialize members in the order they're declared. Oh, okay. Vector origin. Remove this guy, and then index function should be fine. Let's make this. Okay, well that removed the warnings. That's good. Now, what's the next one? Error no match call for constant, constant index, constant sphere, constant index vector. Okay, return index function this p. Okay, let's check. Index function is defined up here, defined in there. No match call for constant index. Wait, what? Where are we? We are in 96. Return index function. Where's operator? Operator is right down here. That seems fine to me. So constant index, double index I, double operator, constant sphere, constant index vector. Okay. Add constant qualifier to operator. I mean, it looks like... Yeah, but have I not already added it right here? Because this is constant, index function is also constant, so operator needs to be constant as well. But const at the end of operator. Here? Okay. Now just a bunch more errors to fix, but that's okay. These are at least errors I can probably find, which is of non-class type constant integer. 1 second. So, invalid use of template sphere without an argument list. Okay, that's fine. We can fix that one pretty easily. Optics visualization.cpp 271. VI optics visualization.cpp 271. Okay, vector double index constant sphere lens. Okay. Let me see. So, you said we don't need... No, I guess we do need, right? So let's go here and add template, type name T. And let's go down here and say sphere of T. Okay, so let's see if that clears anything up. And let's make this. Okay, invalid uses type name sphere without an argument list. 225, okay. So let's just go ahead and fix all these guys up. Template, type name T. Change all these to have a T involved. And let's see, where else do we use sphere? So let's go and see. I bet you there are a few more under here that we have to fix up. Create index texture. Seems fine. Index plot. Yep. Let's go here. Template of type name T. Let's go down here and add a T there. Good. And there should be a couple others down here because I think there are a few index plot functions. So we're going to go here and say template of type name T, and go down here and add in a T. And there should be one more index plot function, I think, under this one. Yep. So I'm going to say template of type name T, and go down here and add in a T there. Now let's scroll down. Good. That seems set. Now there should be a couple more in geometrical.cpp, I imagine. So let's go down to sphere here. There, okay, that seems to be the only time we're using it. So let's go ahead and write this, go here, let's make that. Okay, so it seemed to make, but we have an error. So let's see. Optical geometrical 57, undefined reference to void draw lens constant index. STD vector frame, STD allocator double sphere. Okay, so let me see, geometrical.cpp 57. So it says draw lens, layer 1 lens. Invalid reference, or undefined reference. Devoid draw lens. Okay, so let's see. Constant index. Oh, yeah, you mentioned that before. So let's see. But wait, we're already reading in geometrical or optics visualization.h. Okay, so let me see. Draw lens. Let's go into optics visualization.h. And let's go down to, where is it? Draw lens, I think? Draw lens. Yeah, so it's already templated, is it not? I mean, we are reading in the template for draw lens in the header that is being read into this file. So wait, really? I feel like what's the point in the header file then? Okay, well then I guess we'll just take the draw lens function from optics visualization.cpp, go down to draw lens, And I guess we just take this function and we put it into the header file, which is kind of weird, but all right. Let's go ahead and comment this whole guy out. And comment it out down here. Object visualization.h. And let's go down to draw lens here. Just remove these guys and paste what we got. Write this, go over here, let's make that. Okay. Object visualization, undefined reference to void index plot. Oh, we have to put them all in there. Oh, wow. That's... okay. Fine, I guess. So let's go over here. Go into optics. Oops, sorry about that. Optics visualization.cpp. And I guess we'll just find all the templates. Here's one, draw lens. You want to remove the prototype. But I got to remove them from this file, right? Let's see what happens if I don't remove them from this file. Make. Yeah, okay. So I have to remove them from that file. Let's go to template. And let's remove some stuff. Okay, here's the next one, which we're going to have to put in. And sure, I would just go ahead and leave the function list in there. So let's grab this, paste it there, add in a semicolon there, and let's grab this guy, and I guess at the end here, let's go ahead and create a small box for templated functions. Okay, templates. Wow, that's not how you spell templates at all. Let's, okay, and then we'll just put them down here. And let's paste here. I'll be honest, guys, I am always... templates are hard for me. They are not easy. It's not something that comes intuitively, and I try to avoid them in my normal code. But, that said, it is worthwhile to learn, and I'm doing my best. So forgive me if I've been a little bit slow, or this particular episode has been a little bit frustrating for you guys. That was definitely not the intention. But again, I can only do so much. And I'll be honest, I'm just... let me see, return index texture, so I think the next one is just that. Okay, so I think I can delete this guy now. Oh, oops. I forgot the first two lines. Go up here at the top. Here, and paste these guys. Good, so remove that. Now let's remove these lines one line at a time. Turn index texture, and yes. Okay, so this one is also a template. Let's go add it in. And let's go here. Good. Okay, remove the lines. Yeah, I mean, that's the thing, right? I figure if I'd used them a good bit, it wouldn't be nearly as annoying. And in fact, it's not really that annoying. It's just, it's like learning to program all over again. You know what I mean? And maybe it's not that big of a deal. It's just, again, it is a little bit hard to learn at the start. Okay, so now what do we need to do? We need to remove these lines here. And I think those are all the templated functions. Okay, so then we'll run the code, see if it runs again. Okay, so let's write, one second, write this, go up to the top. I guess there's still a few things and reasons to keep optics visualization.cpp. So now let's make it. And it still broke, but let's see why it broke. Index plot, undefined reference to void index plot. Let me see. Constant index. Okay, object visualization H93, undefined reference to create index texture. Let me think. So I guess we'll go into object visualization.h and go to 93. Well, that's not anything. Set source RGB. Also not anything. Home, project, simulations, simulations, geometrical optics. Optics visualization H, 120, undefined reference to void index plot. And what do we have up here? Undefined reference to create index texture. Oh, did I go into this? My bad. Thanks. Let's go to 93. Index texture, create index texture. Okay. So my guess would then be, let's see, we have animate circle. Oh, what did I do? Did I do something stupid here? Oh, I totally did something really stupid here. What file am I in over here? Object visualization.h. What file did I just open up over here? Optics visualization.h. Yeah, I forgot to write that. Okay. Invalid initialization of reference of type constant simple from expression of type constant sphere. Refractive index at index texture of K. Refractive index at lens. Okay. Let me think. Invalid initialization of reference of type constant simple. Hey, Ikear, what's up? Let me see. From expression of type constant sphere, constant index. Index texture K. Note, in passing argument 1 of double refractive index at simple. Oh, you don't actually. So let's go optics visualization.h and let's go to 179. Here, index texture equals the refractive index at lens location. Invalid initialization of reference of type constant simple. Let me think. Constant sphere, constant index. All right, fine. Simple. Go here. It doesn't need to be anything optics visualization.h. Let's go into geometrical.cpp. Go simple. Here. Okay, that's fair enough. So, but I don't understand why it's having a problem with this. So let me go into optics visualization.h one more time. And let me go to 179. Okay, so for this one, we're reading in constant sphere lens, index texture here. So what I think I need to do is just do lens dot function to create vector double, create index. Yeah, so I think the problem here is if I do this, it should fix it. And let me see, is there anything else I use that for? Nope, let's write this, go here and make. And let's see what happens there. Okay, so this one's doing something. The visualization is going to be really weird at the end though. So let's go here, right quit, geometrical.cpp. And let me just run a simple propagate function. Not the propagate mod, not anything like that, just propagate. Let's take a look at this visualization. And it's gonna, yes, be the same thing all the time. Good. That's basically what we expected. Now let's make this. Give it a second to do its thing. Won't take so long. And let's check that one out. Okay, so now let's take a look at Mirage Temp. And we have exactly what we'd expect. Good. Okay, so we are back to the beginning. Only took an hour and 40 minutes. But we are almost back to where we started. Unfortunately, this is going to take another day. I expected to be done today, guys, and I apologize for taking so long with this kind of stuff. Today's episode may have been a little frustrating, as I've mentioned before, for a number of reasons. I apologize. I totally apologize. Templates are something that, in essence, I think I know, but I realize I don't every time I try to implement them. And I'm sure everyone has something like that, where you've got something you feel like, sure, you have a good grasp on, and then afterwards you realize, no you don't. But that's okay. It's good to learn that kind of stuff. So let's go ahead and close here. Now, I want to see if we can implement this propagate mod function. That's going to be the hard part. So in the propagate mod function, what we're doing is we're reading in a refractive index that varies. Okay, so let's see if we can put that in here. Let's go to geometrical.h. .h. And now let's go into the propagate mod function. Okay, so in here we are basically, it didn't just work a second ago. So, it's kind of obvious why it won't work too. So we changed the index parameter, index max minus start index. We do propagate. So we modify the index parameter, and it is the refractive index. So you don't move the param out of the sphere. It's pretty close to working. There is something that we need to do though. So because it clearly did not work just a second ago, and to show you that, I guess there's nothing better than just running the make command again, letting it run. Yep. Geometrical.cpp. We go down to propagate mod here, and we're outputting all of that. Okay. And then you'll see that it doesn't quite do what we want it to do. So if we go to geometrical. Oh, sorry about that. If we go to the last mirage, we're going to zoom in, and it basically, like, it says the index is changing up there in the upper right, but it's not changing. So, okay. Oh, hey, encrypted cow, how are you? What we should do is index function this p index parameter in this here. Okay, that's fair enough. Let me go to geometrical.h, and let me go index function here. So what you're saying is this, yeah, fair enough. Because that's actually exactly what I want. You're right, thanks. Okay, write and quit, make. Okay, so this is gonna be a really weird visualization, but I'm kind of excited to see it. I'm actually super excited to see it. I can't tell you why exactly, but let's see what happens. Okay, and then after this is just a matter of implementing all of the different functions that we've been working on before. So let's do the last mirage. Okay, let's get through this. Here's the circle. We're drawing the lens. Obviously, they're all reflected at the start, right? Because, well, it makes sense. The refractive index is very, very low on the inside of the lens, so we're totally in the regime where you're going to see total internal reflection. As we go down, all of a sudden some of the rays go in, and this is absolutely cool. Look at this. They are refracting out a way that, well, I suppose is expected. We watch this ray go in, watch this ray go in. It's just so cool. Man. Okay, and then it just zooms in and does what you would expect. Now, one thing to point out is we initialize the refractive index of this guy as 1.4. Let me go into the geometrical.cpp, which we're currently in, and let's give the constant index 1.0. Write this, go here, and let's make that. This way we have a constant index that is exactly what we see in the index function above. And let's take a look at that. Man, I'm very happy we did this, guys. Like, this helped me learn a lot of code, helped me learn a lot of programming, and I feel like, I don't know, it looks good. I like it. So let's go to Mirage Temp. Okay, let's do the same thing we just did. We're gonna zoom down. Here is the lens. Obviously, starts out, all of the rays are reflected off. We go down, we see some of the rays come in. Yeah, look at that. And then at exactly 1 second, we see, bam, all the light going through. No problem. Keep going. We see some focusing, exactly what we'd expect. Focusing. And at some point, around here, the focusing is right at the edge of the lens, which is kind of cool when you think about it. Now, one thing to point out, because this is not, how do I put this? Because this is not your typical lens, like it's not the weird eyeball-shaped lens that people typically use, the focusing is not perfect. We could make the focusing a little bit better if we decided to change the lens that we're reading in, which is something we could work on later, and in fact we did do before, but I kind of left it by the wayside when we moved into the spherical lens. So that's okay. Now, we can go back and we can work on that visualization, and we can make it look really good. But at this point, I'm quite content with how far we've gotten. I really like this. I think it looks really good. Okay, so the last thing we need to do is implement propagate sweep. So let's just make sure that one works, and then we'll have everything set. Man, I love this visualization though. Like, it's just, you make science that everyone knows, and you just make it cool. Okay, so let's go ahead and close this, and now let's try propagate sweep, and let's just make sure that one works. So what am I going to do? I'm going to comment this guy out. Propagate sweep, write this, go over here, make, give it a second to do its thing. Normal at, of course, is broken, so let's go ahead and fix that one up. 250. Normal at, it should be lens. Dot normal at, here. Yes, we can definitely try it with more rays. 1 second, write this, go here, make, let me just make sure the propagate sweep works, and then we'll go from there. Oh yeah, it runs okay. So let's do mirage temp, scroll down, and here's the ray going down, and here it is going back up. Who did you see yesterday, Gothic Death Eater? Was he famous? Or she, could be she. But oh no. Fair enough. Totally fair enough. Okay, so let's run it with more rays. Vi geometrical dot h. And let's just do 200 rays. And let's make that. Oh, ooh, I just did propagate sweep. My bad. Rank quit, vi geometrical dot cbp, down to propagate. 1 second. Propagate sweep, which is what, screw it, it's right there. I'm just gonna go down with my mouse. Propagate mod. And let's make that. Okay, give it a second to run. It actually is not going to take as long as you would expect. It's not so bad. It'll take like a minute or two. In the meantime, how is everyone today? I hope you're doing fantastically. For the record, I do want to point this out. As of yesterday evening, I made a post on the Twitch subreddit about the state of programming on Twitch, because plenty of you guys have mentioned how it is. And so if you want to, feel free to check out that post. I'm not like advertising it or anything like that, but I'm saying if you want to discuss something, that is a good place to do the discussion, I suppose. But I'm just throwing it out there, letting you guys know that it's pretty easy to find, and it's there. Anyway, good. If you guys have any comments or anything like that, let me know. I'm going to get a quick sip of water, and we have about 10 minutes left until I close the stream for today. So let's see how this turns out. Okay. The only other thing I really want to fix, which we might do tomorrow, might try in the last 10 minutes, is that one stray ray that doesn't quite go through the lens. It's the very first ray I think we put out. I think. So I think what we need to do is just move the very first ray, right? And I guess we'll just permanently set the first ray at 0, 0, which is the very start, the origin. And we'll see how that goes. 0, 0 should be the top, I think. Yeah, it is the top. So hopefully that's good. Okay, so now let's take a look at these images. Simply go to Mirage, and let's scroll down. So here's all the rays. Obviously, they're all reflected to start. Now, this is kind of the neat part. Before, it took a couple frames before we got to the point where light started going into the lens. But here, within, we have very little refractive index at all, and we're already seeing light start to come in. More and more light comes in until eventually we get to 1, somewhere in here. Sorry, it's not quite 1. Then we zoom in, and we see this. Now, obviously, if we increase the size of each of the rays, we can make this look better and better, which is what I was intending to do at some point. So if we increase the line width, we can make this look really good, I think, and lower the alpha value of each of the lines. But that's okay. I think it looks pretty dang good as is. Something that we can definitely work on in a bit. But yeah. I don't know. I like this visualization. It's quite nice. It doesn't... Again, it's not a matter of really showing... I don't know. It's just cool. Okay, so that one stray line, let's go ahead and fix that line. And while we're at it, let's... Why not? We'll mess with a couple of other things and run that very same visualization one more time. So, the first ray, let's go into light gen. Here it is. And here we say I equals 0, I less than raise.size. We say position is going to be 0, 0 offset. Do what I did and render each color channel with a slightly different refractive index to emulate chromatic dispersion. Do what I did, render each color channel with a slightly different refractive index to emulate chromatic dispersion. Yes, we could do that. Each color channel. I have to think about how to do it though. So let me think. We have red, green, and blue. And you want each one to have a very slightly different index. Yeah, I guess we could do that. Yeah. It just means putting in 3 times the number of rays and overlapping them appropriately. Sure, yeah, we could try that. Yeah, we would only need to change refractive index that to return a color. Yeah, I don't think it's that big of a deal. We might look into that tomorrow. But first I want to implement a whole bunch of different lenses before doing that. And then we can try that afterwards. So, Zadistan, be sure you remind me tomorrow so I don't forget. Let's just go ahead and move that one ray to where it's supposed to be. So, up here we're going to say if... Super simple. If... We're going to start I equals 1. Oh, what? And then we're going to go down here and we're going to say if what's the best way to do this? I guess we'll start it at 0. Nah, it's okay. We'll start it at 1. And we'll go up here and we'll say raise of 0 dot p is going to be equal to vector of 0.0, 0.0. Oops. Then we get on here, we say raise of 0 dot v is going to be equal to velocity. And finally we say raise of 0 dot refractive index, previous index. Oops, misspelled previous. Index is going to be equal to lens.refractive index at this guy right here. Good. Let's write this, go here and make it. Error, I was not declared in the scope. What? Oh. Of 0. What am I doing? Undo that, go into the end, change this to a 0. There we go, write that. Let's go here to make. Okay, now we'll give it a second to do its thing. Oh, I forgot to do one more thing. Sorry about that. Let me go to, let me see, where do we do init? Couple of different things I want to do then. Let's right and quit. Then we want to go into Geometrical Optics visualization dot CPP, I think. Let's go down to init. We set line width, let's set it equal to, instead of 1, let's set it equal to 2. Okay, now let's right and quit. And what else do I want to try? I want to go, what do I set RGBA equal to? Set source, do I set source RGBA? No, it looks like I might not. So let's go into geometrical.cpp. Wrong one. Geometrical.cpp. And let's see, I want to go to propagate. Here it is there. And I guess it's propagate mod, but that's okay. Let me just go down to Cairo set source. Yeah, that's what I want. Here we are. RGBA, white.alpha. What did I set white.alpha to be? I set it to be 0.5. Let's drop it to 0.25. And this is in, that's in propagate. Keep that one 5. Propagate mod. Here we are. And let's change this to 0.25. Okay, it gives it a second to run. Let's make it. And let's just see what it looks like with a little bit thicker lines. It's not going to take too much longer to run. Hopefully it'll look a little bit better. again, it didn't look bad last time. It was just the issue that the lines themselves, I feel, could have been a little bit thicker, and it would have made it look a little bit cleaner. But that's about it. After the simulation is done, we'll take a look at it, and then I think we'll call it for today, guys. There isn't so much left to do except implement the different functions, or implement the different functions for the lens functions. Sure. And then let's try that chromatic dispersion thing, which we'll try tomorrow. I have to kind of think about how to do that. It's not that big of a change, but I still have to kind of think about it a little bit because obviously if you know what you're doing, it's easy, but if you know what you're doing, everything's easy, right? So that's something to look into there. I'm actually quite excited. Again, I've mentioned this before, but I'm really liking how these visualizations are turning out. I'm probably just going to make this video this weekend, and then we'll go from there. I actually like small gaps between the lines, but I'm curious about this. Yeah, we'll see what it looks like. Worst comes to worst, we just return it to what it was before. In fact, let's keep it like it was before, just standard. So let me go look for a 2. Well, that was easy. Okay. Good. Give it just a second. We're almost done. Now it is drawing all the frames. And then we'll be good. Done. I don't know. But seriously, guys, thanks so much for coming in. You guys are really great. As the gap's reduced to the point where it's a sub-pixel distance, the output becomes closer to what you expect in real life. Yep, that's about right. Give it a second. Still kind of making the images. Luckily, I'm not converting it into an animation, so it doesn't take as long. Okay, there we are. And let's go ahead and open up Mirage. Okay, so let's see what we got here. Here's that. There's that, and okay. So we still have the lines. That's okay. And let's see what it looks like. It's okay. It looks better, in my opinion. Obviously, if we increase the line number or something like that. I don't know how this is Monte Carlo, but yeah, this is pretty far from Monte Carlo as it currently is. Yeah, so if we increase the line number, this will actually kind of sort itself out in a way. Truth is, we'd have to increase the line number by a good bit, so by an order of magnitude probably, to make this turn out to be what we want it to be. So we might want to keep the line width small and just increase the number of lines by a significant number, and then go from there. Here, I'll go ahead and go back to the start. Okay, so here's where we start. We draw the lens, put something in, and go from there. Yeah, numerical integration, yeah. And good. I say it looks pretty good. Okay, so tomorrow, first thing we're going to do is implement all the different functions. We're pretty much there, guys. And then after that, we need to... What do we need to do? Let me think. Implement the chromatic dispersion thing, and we'll see what that looks like. Worst comes to worst, we don't like it. Best case scenario, we like it a lot. That's the way I see it. Again, this visualization is a little bit slower than I'd like it to be, but that's okay, you know? It's not like we need it to be in real time or anything like that. So let me go here, right quit, go into vi geometrical.h, and what I'll do is I'll go ahead and commit this current version of the code to github.com. So let me do git status dot. Looks like we updated geometrical.cpp, geometrical.h, opticsvisualization.cpp, and opticsvisualization.h. The make file, I believe, should remain the same as it is on GitHub. So let me do git diff makefile. Yep. Yep. I know yours is real time. I'm sorry. Let's clear that. Let's do git add geometrical.h, geometrical.cpp, opticsvisualization.h, and opticsvisualization.cpp. Let me do a quick git status. Oh, git status dot. Okay, I'm not going to add the make file geometrical.gp because those changes were not big enough to really warrant adding to the directory. Good. And so let's go ahead and do... No, don't worry about optimizing this code, guys. It's done. I'm not worried. This code is not... No, the thing is we're using Cairo to draw it, right? If we're using anything else to draw it, it'd be a lot easier. But unfortunately, there are limitations to using Cairo for this kind of stuff. I've gotten used to it. I know how it works. but it's definitely something to think about. You know, maybe we should worry about another 2D visualizer or something like that in the future. Anyway, let's go ahead and do git commit. And we're going to say adding templates sphere struct for, let's say, different index functions to be added later. Okay, run quit, git push origin master, and good. Okay, so even though today was a little bit slower and a little bit frustrating at times, we still got a lot done, and I'm quite happy with how far we got. So it's a matter of getting everything working and kind of going from here, and I'm really confident that we're going to be done within a day or two with this visualization, and then we'll move on to the next one, which unfortunately I don't have completed yet. So what we might do is coast this one through Friday. I'll take the weekend off to basically make the next YouTube video, and after making the new YouTube video, also looking at the next thing, which I would love to be conformal mapping because it's super cool, and then we'll go from there. So if you guys have any ideas or suggestions, feel free to let me know. I have a big list of suggestions of things that I want to go through at some point. So if you have further suggestions, let me know and we'll go from there. But at this point, guys, I'm going to go ahead and end the episode here. So have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we continue working on random visualizations here and there of this lens. And again, I know we've been working on it for a while, but we've been getting better and better as we get along. So I'm quite happy with it. And that's that. So again, thanks for watching, and I'll see you next time. Bye, guys.